Hey guys, welcome. I hope that this video, like it does to me, brings you joy and happiness because it reminds us of days gone by. This should feel really, really familiar because you've been watching these correction videos all year. So let's get to it. This is just the beginning video, and I probably won't go through question 1 through 15. That's what's due this week. So question number 1. A professor conducted a survey, and he did it against 34 students, and he's looking to see the cost of their course material. So the kicker here is that we don't know how the 34 students are distributed here. We just know the locations of the 5-number summary of students in each type. So we kind of know that there's a non-nursing student that paid $680. We know that there's a non-nursing student that paid around $490. So 1, 2, 3, 4, 5. That's the 5-number summary. We actually know 6 pieces of information. So what could be happening is there may only be five nursing students out of the 34 that they talked to, these 5 right here. You see what I'm saying? And so then this could be 29 other students. So that's why I picked E. Hope that makes sense. Okay? So feel free to pause and kind of jot a few of those ideas down, and make sure you try to put it in your own words so it helps make sense. Let's say it still doesn't make sense. Guess what? Fridays, I'm open. I'm also open from 10, like 30 something to 11-ish. So you can ask me in those windows of times any question. I'm here to help. Okay? All right. Question number 2. In order to compare the real estate market, we looked at two cities. Now, these are actually in the same state, and they're not far from each other, but they're totally different. So in Philadelphia, look at the variability is much shorter. Okay, so in Philly, you can buy a home for anywhere from $300,000 to a little over $800,000. In Pittsburgh, it looks like you can get a small, maybe crappy, maybe bad neighborhood house, very cheap house in the $70,000 range. But it looks like there's some really million-dollar homes. Okay, so when I look at these two distributions, what I'm really noticing is not necessarily the mean. The mean is not, the number in the middle is not that far away from each other, the median and the mean, but the spread outedness is very different. So they didn't give us specifics. We're not calculating anything, but it says the mean home for both cities is about $500,000, and I would agree. The standard deviation, so that's a typical amount that any number is away from the mean. So I would say that in this, here's the typical value of a home in Pittsburgh. And so it looks like it's about $200,000 to $300,000 away from the mean, a typical one. $200,000 to $300,000. Yeah. So this is definitely Pittsburgh. Right? Now, what does the standard deviation look here? Well, it looks like, I don't know, about 100. Yeah, maybe a little bit more than 100. This is, most of the people are within 100 of the mean. So this one has to be Philly. Okay, so what would the answer be? C. Let's compare the variability above. So what is variability? It's the spread outedness. Not sure that that's an actual word, but spread outedness. So think about peanut butter on a piece of bread. The peanut butter spread across the whole piece of bread. Here, there's no peanut butter here, just clumped there in the middle. Spread outedness. Question number 3. The segmented bar graph shows 44 presidents who have died in office. Okay. Classified by the political party. What proportion of the presidents have died while in office? So we know that there are 44 presidents. So when we want to make a proportion, that's what's going down at the bottom. And then what proportion died? So 4 Republicans died, 2 Democrats died, 2 people from another party died. So I added those up. Okie doke. Question number 4. The grocery store manager wants to estimate the mean purchase total of all customers at the store. So most customers are spending in this range, anywhere from like maybe $10 all the way up to about $180. So this is similar to a small grocery store maybe. I think that's a typical purchase. So if somebody comes in and spends $500, be like, wow, that's kind of weird to go into 7-Eleven and spend $500. That's pretty rare, even if you bought gas. So most purchases are not that big. So she's asking, what if she removes this number? How will that change? Well, think about this as your grades. So imagine this is usually the scores you get on your tests and quizzes. And then you have this 1 that you get way up here. This 1 is driving up the mean. So although the median is here, the number in the middle, the median is going to be somewhere to the right of the mean. And that's why we call this right skewed, because the mean is skewed to the right. The mean is to the right by this number. So the mean would, if I took it out, the mean would then jump pretty much closer to the mean. So the mean would decrease more than the median. In fact, in this scenario, the median might not even change at all. So depending on if there's an odd or an even number and the exact values of those, so we do have 30 customer receipts, this dot could be the median before we take it out, and then now this dot is the median after we take it out, and that wouldn't even change the median at all, with or without that dot. And that's what they're trying to get you to understand in this question. All right. When a homeowner lists their home for sale, they begin to list the price that's greater than what they receive. The longer it's on the market without being sold, the more the price drops. Okay, so this X would be the number of days on the market. And so it looks like it's dropping for each day. So at day 2, it would be dropping 400. Day 10, it would be dropping 2,000, that type of thing. So additionally, it says 85.4% of the variation can be explained by this least squared regression model. That is R squared. So the minute they told me this information, I know R squared. So let's take a look. They give us the equation, the expected value you can expect to get if you sell your house is equal to $245,000 minus however many days are on the market times 200, because for each day it's on the market, it's dropping by 200. Okay, so we know because the slope is negative 200, we know R is negative. So when we take the square root of both sides, we get R is equal to plus or minus 0.924. So because the slope's negative, we know it has to be negative 0.924. All right, last one, and then I'll squeeze the other ones on the other video. So let's do it. This one's kind of a weird, tricky one. So let's take a look. We have some data about some active energy drinks, and here's some of the data, and then here's some other data. And the reason why it's maybe different is because these are athletes. These are actually people in different physical condition than these. So what they're saying is, what would change, and specifically what would increase if these football players, these 4 people, were eliminated altogether? So I'm going to have to draw the data set over again and think about how the calculator would create the least squared regression line if all I had was this data. Okay, so if all I had was this data, it would look exactly like this, right? And the problem with this data is once you take these football players out, my least squared regression line doesn't know what to do. It would probably do something like that. It doesn't know. It's just trying to put the squares above it equal to the area of the squares below it, and the squares are made from the distance from the least squared regression line. So if that, I don't know if that makes sense, but that's probably where your least squared regression line is. So if you eliminated these dots here, you now just have this data. That's all you have, and that's your least squared regression. This is your least squared regression line before you eliminate those football players. So what would change? Well, a couple of things would change. The slope would change. A lot of stuff would change. But what would increase? Well, it looks like my slope actually decreased, so not that. R and R squared, that's how strong the dots are. Well, what would really increase the most would be S, which is a standard deviation of residual. And I'm going to explain why, and hopefully then that'll make sense. S is how far away, on average, is a typical dot from the least squared regression line. Okay, so a typical dot. Notice these dots are really, really close to that pink line. So if you remove them, now these dots are, they're not very far away from the blue line, but these 4 dots were much closer to the line than these were. So if this data wasn't in there, the standard deviation of the residual would go up. Okay? Awesome. Check out the next video, which I'll probably post in another couple hours. I got to jump into a class here. And just go up to number 15 this week. Thanks for joining me. Take care. Have a great weekend.